Question 10 asks, a charge is accelerated from rest through a potential difference V and then enters a uniform magnetic field oriented perpendicular to its path. The field deflects the particle into a circular arc of radius r. If the accelerating potential is tripled to 3V, what will be the radius of the inner of the circular arc? So all that this is asking is if we triple the accelerating potential value, then what will happen to the radius r? So first we need to consider that V in this scenario is equal to the square root of 2Q times delta V divided by M. So in a regular scenario, R is equal to MV divided by QB, which is equal to M over QB times this right here, basically, because we just copy in B times the square root of 2Q times delta V divided by M. So then we move on, and it continues to just be equal to 1 over B times the square root of 2M delta V divided by Q, which occurs when we just move in some of the values into the square root. So now when we ask ourselves, what would happen when we triple the value of the potential, right? We'll call it R3. And now that's going to be is equal to the same exact thing, but we're just going to go ahead and multiply a 3 to the potential. So when we go ahead and we just take this out, take the 3 out of the square root, we see that R3 is equal to square root 3 divided by B times the square root of 2MV over Q. Sorry, should be written like that actually. So look up here, and then basically these are these two equations right here are basically the same exact thing, except for one little difference, which is this right here, the square root of 3. So we could say that now R3 is just equal to R times the square root of 3, which we see right up here. And that's it.